Hello and welcome to Azure Community Conference. My name is Nandeesh. I work as a technical advisor at Azure Rapid Response in Microsoft. I'm responsible for keeping Azure as the charm for some of the top companies at Microsoft. I love public speaking and I talk at all the major events at Microsoft. You can connect with me on Twitter at Nandeesh Swami, LinkedIn again at Nandeesh Swami, and I run a Facebook page called the Dev TV. Happy to connect with you on any of these platforms. Today, I'm here to talk about serverless trends of the season. Without further ado, let's get on with it. What are the important takeaways? The first takeaway, what I would want you to take away from the session is understand serverless app and its trends, right? Clearly understand what are the trends that are running in the market right now and have a good understanding about serverless apps. The second takeaway would be to understand how Azure Functions tick all the boxes for a well-rounded, matured serverless ecosystem. Effectively architect your apps with up-to-date serverless components. The thing is, I'm going to discuss about the trends. We are going to dig into how the architecture is, what are the important components, what are the important do's and don'ts, and then we will discuss some of the use cases. And that should probably help you effectively architect some your applications with serverless components. All right, let's get on with it. Here is how we're going to discuss the context. We're going to set the context with the trends, evolution, what is serverless, and a brief demo, and patterns and anti-patterns. These are the do's and don'ts that I was talking about. Then we're going to discuss about security, durable functions, use cases, and then to summary. All right, let's see what are the trends as our title signifies, the trends. Okay, first of all, let's be clear about one thing, right? There is a linear growth of serverless components. It is the most used platform. It is having the fastest growth. This is just from the search trends as to how from 2014 to 2020, how the search trends have increased for serverless. Like I said, serverless is the fastest growing cloud service model right now. There's an annual growth of 75%, and this is not me. This is RightScale State of Cloud reports that is saying that. You can go and check it out. All right, moving on. All right, some of the things that are really important right now and which are trending in the serverless world, people really care about integration. When I say integration, serverless will probably mainstream into enterprise applications or microservices. It will not just be limited to one or two components of your application. Probably an entire application may be made up of 90% of serverless components, right? And I think you can probably expect a lot of integration into traditional application architectures. And then security is very important. There's a company called PureSec who did an evaluation of open source serverless project, and they found some vulnerabilities. We will discuss as to how Azure Functions and some of the serverless components inside Microsoft Azure are so, they're really secured. We're going to discuss about those points in our upcoming slides. And then observing and monitorability will be key. High level of abstraction of serverless architecture, because of course, I don't want to, I don't want to really get into it because we're going to discuss about all that. But definitely one of the most important points of serverless components is that there is a lot of abstraction. You really have to think about just the code. So there is a high level abstraction which happens, and because of which you might lose your eyes on the data, your eyes on the code while debugging or in production scenarios or in deployment scenarios. So observing and monitorability becomes very key. And the programming models and tooling. How is the support for how's the support inside IDE? Is tooling matured? Can we use the tools in most of the scenarios? Things like that. Is there support for orchestration and things like that? All right, we have established the trends. We are clear that serverless is big in the market, and some of the important trends. These are the references that I went to. There are so many articles which talk about it. You can as well go ahead, but according to me, these were some things that I saw which would really matter in the future. And let's see how Azure Functions or other serverless components inside Microsoft fit into this trends. All right, let's understand the evolution. How did it all start? We're going to talk about the different applications that were there since the age-old days, probably like 20, 30 years ago till now. We started with monoliths where the entire code base was one, like UI, business logic, and storage. Then we evolved into entire, where we made this differentiation of the UI layer, the logic, the business logic layer, and then the data access layer, and then the database, of course. Then in these modern days, probably like, I'm not really sure about the date, probably about 10 years ago or 8 years ago, we started evolving into microservices, where again inside business logic, can we again branch into some more microservices? Can we have a different microservice for authentication? Can we have a different microservice for some kind of business logic? Can we have a different microservice for putting out data into database? Things like that. So microservices. And then what I want to really also talk about is what are these hosting models right now, right? I mean, these are the three different types of architectures that we know, but how do we host it? I mean, of course, the traditional on-premise, where you have your servers, you can pretty much go ahead and host them. You may have to buy additional servers in case you want to scale. The same thing applies in IaaS, but of course, it's in a virtualized environment where it's sort of like running in like, let's say Azure VM is more of a virtualized, but then again you'll have to still, if you want to scale and all that, you may still have to buy servers, and it really depends on that. And then there is PaaS, of course, where platform as a service, you don't really have to worry about a lot of different things. Most of it is managed by Azure, and you will just have to deploy your application, write code, deploy your application, and pretty much be done with it. And then we have software as a service. I would probably stack it up with PaaS and IaaS, because here you don't really have control on anything. Office 365 is one of the great examples of SaaS. Then we have something called containers and orchestrators, which I consider as a step up from from probably the traditional IaaS and PaaS world, where we have something called orchestration. We have containers. You probably don't. I mean, just to give a simple definition for folks who don't know containers, I'm pretty sure most of you, or almost all of you, know what is containers. But basically, containers are those small pods where you will probably have. You don't really deploy the entire application. You'll just have the subset or the small at the ecosystem, which you will go ahead and deploy on containers. The Docker is a great example. And then these containers or these servers, shouldn't call them servers, but the containers, there are scenarios where your application can go down or the container can go down, right? How do we orchestrate it? How do we ensure that there is a very high availability? That's when orchestrators come. Azure Kubernetes Service is a great example of it. And then finally, our serverless. This is a simple, this architecture that we are showing here is a simple, it basically is nothing but an HTTP trigger. I will discuss as to what HTTP triggers are. Then this symbol is what is Azure Functions. What is serverless is basically that, it's just gonna run, when and as and when required, it is gonna spawn and run. Serverless is probably, it should be called less server. There is a server component obviously involved, but there is less of it. It's only utilized as and when required, right? High density microbilling, because obviously we run as and when required. Instant scaling, right? Like, if you, let's say you have one of the serverless components as a backend, as your functions, let's assume that, and you start hitting a lot of requests to your server, and in case needed, there is automatic scaling, which happens instantly. And probably because you're not really worrying about a lot of different things here, your product will come to market as soon as possible. All right, this is just a high level definition, or probably a discussion on a very high level. I wanted to set up the context as to how we evolved from where were we and to where we are right now. So let's discuss about Azure Serverless Platform. There are mainly three important components in Azure Serverless Platform. First one, event grid, logic apps and functions. Event grid is probably, when you need a large scale, event mechanism where you want to send events across. That's when you use event grid. Logic apps is probably that workflow kind of a thing where, you pretty much like, if there is a Twitter If there's a tweet that comes in, go ahead and do this, go ahead and do that. It pretty much works on that. And the reason it's serverless is because it will be waiting for that event to happen, and that's when it will do your stuff. You can use it from, you can use it anywhere. It need not be just in Azure. It can also be utilized in on-premise world as well. And the most important part of this discussion, Azure Functions, where probably my entire discussion today will be around, is basically you execute your code based on the events you specify, right? I mean, Azure Functions it's basically a unit. Function is a unit where the code that you have written would probably run, and you would be able to pretty much, you don't have to do anything with respect to maintaining all that. It's just that you write the code, focus on code, and then go ahead and deploy it in Azure Functions, and it will pretty much run as and when required. There are multiple, it's a trigger. There are a lot of triggers that can be utilized. There is something called HTTP trigger. Then we have Event Hub trigger. Then you can utilize Cosmos DB for triggering as and when there is data coming into it. You trigger a function to run. HTTP trigger, as the name defines, when there is an HTTP, when we go ahead and do an HTTP get or something like that, that's when it gets triggered. So there are multiple triggers, and you can utilize them, and then you can utilize it across database storage, security, IoT, analytics, and intelligence. Across all these you can utilize these platforms. All right. Now let's get on with function architecture. How is the function? How is Azure Functions laid out? So at the bottom is Azure App Service. Azure App Service, for folks who probably wouldn't know, and I'm pretty sure there would be a lot of questions. App Service is something like a Blaze platform where where you probably host your applications, web applications. Azure Functions is also hosted an App Service, and then we have this web job score. And then we have language runtime, where, as we know, Azure Functions is supported in multiple languages, and you'd probably the language runtime supports that, like C#, JavaScript, and others. And then you have your function code and function configuration. I will talk a little bit about function configuration in our upcoming slides, but basically function code is your code that you're going to write. And then function configuration, there are files like host.json where you can provide a lot of settings for your functions. I will probably show them in one of my demos. And yeah, this is pretty much how function architecture is laid out as. All right. So what is the serverless code model? I mean, just to give a simple example, I mean, I was just talking about function configuration in the previous slide. This is how it's laid out. You can see the code that, simple example without output is your code. That is the name of the class. And then this is function.json, where you pretty much have your configuration, right? Where you have things like, is it a queue trigger? What is it like, what is the queue name, and what is the version of SDK and things like that. If you closely see what we are doing here is basically, this is a queue trigger. Like I said, there are multiple triggers. Queue trigger is also one of them. And you can see that it is taking a queue item, and then out string my queue item copy is the out. It is basically what is it going to be outputted as, the binding. And the binding is, there are some key concepts that are there in functions. The upcoming slides will talk about it. But basically what this function is probably doing is, here is where your business logic will come, and what this signifies is that as and when there is an item coming into the queue, run this code, and we probably write some stuff here, which will execute, as and when the item comes into a queue. All right. Let me do a quick demo. Let me switch over to our favorite IDE or favorite coding environment, Visual Studio Code. Okay, we are in Visual Studio now. So it's pretty easy to create any project inside Visual Studio. Let me show you how we can easily create Azure Function projects. There is a shortcut. There's something called command palette inside Visual Studio Code, and the way to bring it up is using a shortcut with Control-Shift-P, and you can see you can do a lot of different things in the command palette. One of the things that you can do is Azure Functions create new project. If you just click on that, it will ask you for a particular folder where you want to create. Let me give one folder, create a folder here, new py Python. Select this folder. Okay, then it will ask you for which language do you want to create it in. Let's select Python. Let's select the latest version, and then it will ask you for the templates. These are the templates, but essentially you can also see what are the different kind of triggers that are there in Azure Functions. HTTP trigger, timer trigger, blob trigger, blob storage trigger, Cosmos DB trigger, event grid trigger, and many others, right? Again, these are templates, right? I mean, because you can also see something called durable functions, which we're going to discuss in the upcoming slides. But yeah, I mean, these are the templates for now. Let me select something like HTTP trigger. Let's name it HTTP trigger py. Let me give authorization level as function, open in current window. So straight away it just goes and creates your virtual environment. As you can see here, it's creating the virtual environment. That's okay. It may take a minute or two. While it does that, let me try to head over to, okay, it's already created that. Okay, that's awesome. Fine. So we were discussing about the function code. Your function code is probably gonna be here in init py. You can see the, I mean, for those folks who who know Python, it's as simple as it is just your main function. It is basically taking some values. It's an HTTP trigger because, I mean, if we run this, the idea is that it is going to expose an URL where you can go and run that, and it is going to give you some kind of a response. We can try doing that. Let me run that. And by the way, you can debug, deploy, you can do everything from Visual Studio Code when it comes to Azure Functions and many more projects and many more function application types. So I'm going to press F5 now to start debugging. In fact, you can even set breakpoints, which we're going to show in the upcoming demos like this, and pretty much give you the same kind of experience. All right, let's just run it. Okay, so it's running now. And it's going to bring you all that information, and you can see that it's basically listening at this port. Let me copy the URL and then run it here. Okay, so it ran. It says this HTTP trigger function executed successfully. Pass the name. Basically, it is expecting a name. I can give it in a parameter, and then it will take a name. But then, yeah. Okay, fine. Let me go back. I mean, we have another Python sample here. Okay, this seems to be some. Okay, fine. All right, let me stop the debugging in this environment and head over to the Python sample. This Python sample is basically very straightforward. It talks about it's basically calculating the value of Python. Here is the function which does that, and it is a similar type of application as we just saw before, where it has its function, and inside that function, and this is one of the functions, digits of Python, and here is your main. From the main we are calling this function, and inside this function we are calculating the value of pi 22 by 7. It gives you, it asks you for input, and based on the input it calculates the value up to those many digits. Like if you say 10 digits, it's going to calculate the value up to that many decimal numbers, and that's the overall logic here. Let's try running this. Okay, before we do that, I want to show you something here. Basically, it's expecting the number of digits that we're going to provide as an input, as I just mentioned. So I think when we are running this, we should ensure that we give the digits input as well, otherwise it's going to error out. So let me just run this like we ran before, and you can see that it is starting. It is going to start the runtime, and it's pretty much starts here. Let me copy that like last time. Okay, we are here. We can say digits equal to 20. Okay. All right. So you can see, I mean, ideally, if I remember from my math classes, it was 3.142, but since we gave us 20 digits, it's calculating the value based on that. And that's how you run or debug locally. Uh, and it's pretty straightforward as well to deploy your applications. I'll show you how. As we know, there are a lot of extensions inside. Oh, I forgot to talk about the variables, watch, and call stack. It's pretty much like, the Visual Studio experience that you get. You pretty much get that here. Now we have something called extensions, like I said before, and you can install a lot of different extensions. I have installed the Azure Functions extensions here, and so these are the different subscriptions that I have. So inside, let me try to go ahead and deploy that and show you how easy is it to deploy it. Let's select my subscription. All right, it's here. So I've already created a lot of samples. Now what I'm going to do is probably just deploy in one of them and see, okay, here is one. I can probably do this. Okay, let's select this and I'm going to deploy it here. Okay, and let's see. Let's select this, deploy to a function, select the subscription. So I'm just going to show it again. I'm sorry. So what I did was if you just hover over here, it shows you the different. It says deploy to function app. You just click on that, and once you go there, it asks you for the subscription. I select subscription, and then it asks me, do you want to create a new function or do you want to use an old function? It's pretty much up to you. I can probably select an old function and see. Are you sure you want this will override? Because I was already doing some kind of testing. I'm fine. Let me go ahead and deploy. Okay, so here if you see, it start telling you deploying to a testing agent, check output window for more information. If you go to output window, it says starting deployment, creating zip package, patching package, cleaning up temp folders. It's pretty much doing the deployment from Visual Studio Code, and that's why it's more handy. And it's starting up Oryx build. The tooling inside Visual Studio Code for Azure Functions, or in general tooling for Azure Functions, is very mature. You have a lot of different options. In the next demo, I'll probably show you how to do that from right from portal, how to run your function apps and test them from portal directly. Okay, deployment successful. Okay, I think we have the URL here. Let me copy that. Okay. So there you go. It's pretty much doing the same thing. All right, that's pretty much it. You can pretty much debug, run, deploy, do everything from Visual Studio Code. Now, since that is established, let me head back to the slides. Now that we are done with serverless demo, and you can pretty much see what we did, right? We didn't really have to do anything. We just pretty much wrote the code and just in clicks just deployed it, and all I really had to do was focus on the code. I don't really have to be worry about how and when the deployment is happening. All right, now moving on, some of the key concepts inside function app. Function app is basically a unit of development and deployment, and there can be multiple. For instance, let's assume that there is a food ordering app. You have let's say a function which takes the order and then it processes it, and then then again it stores into data, and then there is another function for delivery, and then you have another function for rating, and pretty much that, right? I mean, these are different functions. Let's assume that these are different functions in the same application, something like a microservices kind of an environment, right? And it can have multiple triggers as well, right? Like triggers, we talked about triggers. We saw that also in Visual Studio Code. It's basically an event source that starts the function. You can have at maximum one per function. The different triggers are HTTP, time, queue, blob, Cosmos DB. We saw that, and the processing function will only instantiate if there is an order. Like when I said here, if I was saying that if there is an order, that's when it's going to run, and that's when you're getting charged, right? All the other time it is not really running and you wouldn't be charged for it, right? That is the magic of serverless. And then we have something called bindings, right? There is input binding as well as the output binding, right? I'll show you a cool demo in the upcoming in the coming minutes, where you don't really have to do a lot of things in order to set an output for like let's say I want to output my data that is coming to a Cosmos DB. There is a very straightforward way of doing it, and that's what I'm going to show in the demo. In simple terms, input is basically the data that is getting pulled into the function at the start of the execution, and output is at the end of the execution that gets pushed out. All right, move on. So where do functions fit? So functions fit, in scenarios where we are like processing on top of event streams, like the streaming, IoT streaming, event hub streaming, anything like that. Like as in when you receive stuff, run them. Web API and mobile backends. I know one of our customers who have their mobile backend running on Azure Functions. It's pretty easy for them because they don't really have to worry about a lot of stuff. As in, it's basically as in one when they have data flowing into the functions. I mean, data flowing into their queues, the function app gets triggered, and it pretty much runs on it. A glue between systems, that's also one of the interesting scenarios, and it works really well in scenarios like PubSub, like messaging like service bus and things like that, publisher subscription, and of course automation and automation scripting and jobs. Okay, one more demo. This is a very cool demo. I was just talking. We just saw our demo in Visual Studio Code. Now let me head over to Portal. Inside Portal, we can pretty much do a lot of stuff. I will show you how to do it. Let me head over. Here is the function app that I was talking about. This is function app that I've created, and this is the basic structure of the function app. You have functions here. You have events. You have app files, proxies, deployment. And then there are these settings which which pretty much gets utilized in a lot of different scenarios. I was talking about the monitoring tool, and this is the monitoring tool that that is really cool. Application insights, we utilize this for a lot of different scenarios. It helps you understand the failed requests, server response time, server requests, and many other things. All right, so let me head over to the function that I was talking about. Here is the function that we had created. It's basically again an HTTP trigger function, and just to show you how easy it is to create functions here, you can just like in Visual Studio Code here in Portal, it's just pretty much you click plus and that pretty much brings you the triggers. These are the different triggers fundamentally that you can use and create your function app. What I have done is I have already selected one of them, which is HTTP trigger, and here is what shows. So there is something called integration. If you go to integration, it shows you how you can integrate to different kind of systems. What I've done here is I'm pretty much giving input on my own, and then I have set as output as Cosmos DB. That's what I was talking about. And what this shows is, I'll just show you, you can pretty much add output to many other scenarios as well. Here binding type is Azure Cosmos DB. We talked about binding type as one of the key function concepts. Here it is Azure Cosmos DB. Then we have task document, database name, collection name. It's gonna write to this database and this collection, and here is a DB account that I've given. We already have a DB Cosmos DB created. Fine. All right, that's good. Now inside Portal, we can pretty much test it. I wouldn't really suggest this for production scenarios, but this is really cool where you can, if you want to do some simple tests, you can always do it here. This is a C# file, and let me show you the code. Pretty straightforward. The output is a task document which we had just I just showed you as one of the binding types there, and then it takes 3 parameters: name, task, due date, and things like that. And in case if it works, it's going to give you an okay result. Let's try running this. So I've already done some kind of testing already. It is taking name as, let's give it as Nandeesh. All right, and okay, we don't need the body. So let's run it. It's connecting. This is a log stream where you can pretty much see what is happening. So it gave me an okay. So basically it is inputting the data there. Okay. All right, we are inside our Cosmos DB. Let's me go and figure out if the data that we wrote is already written. We gave the name as Nandeesh, and here is the database, the collection. Let's go inside items. These are some of the names that we wrote. What is the latest one that came in? It is Nandeesh. All right, so we pretty much are able to run the data, input the data with very simple steps. You can pretty much see what we did. We pretty much gave, we didn't do anything. We just gave one of our output as Cosmos DB here, utilizing the binding. And inside our code, it's a straightforward code. Let me show you the code as well. It's pretty straightforward. It takes a task document as an output, and it's an HTTP request. It takes 3 inputs, and we just say the output as task document, and it returns an OK result. That's all. Pretty straightforward. And let me now do a quick test where we can show what is why do we really need the monitoring tools and what are the different options. We already explored application insights. To do this test, I have part of my command prompt, and I'm utilizing something called artillery. What this is used for load testing. It's gonna hit my website multiple times. Here is the website. I've already copied that in the interest of time. What it's gonna do is it's gonna hit it 1,000 times. I think that's not really needed. Let's do it like 100 and see what happens. What it's gonna do is it's gonna hit my website 100 times, and with the inputs, like what we said before, it's gonna probably input it 100, those many times. And let's run it. It's starting phase 0. Duration is 30 seconds, and within 30 seconds it is gonna start writing. Okay, it starts here. CPU usage of artillery seems to be very high, which may severely affect its performance. So it's gonna start hitting. Okay, elapsed time 20 seconds. Alright, elapsed time 30 seconds. Okay, now while it's doing this, okay, it seems to be timing out. Let us stop. I think we're good here. We did do some load testing, and I expect that to be seen inside our application insights. Let me go to application insights. Here is our application insights. So one of the reasons why we need application insights is it pretty much shows you the number of server requests that came in, and how was the server response time, and all those things. Let me go to, there are a lot of different tabs here: availability, performance, failures. It's going to show if there were failures. I was doing some testing yesterday, and it shows that there were failures. I was trying to fail them. There was different failures. It also shows you dependencies. We don't have anything here because nothing is really failing. And same thing, same kind of tab in performance as well, where you can figure out if really there is anything throttling. You can see that we triggered HTTP. We did trigger it. It is showing up here, and then we have. So now let me try to see the number of instances for the command that we ran. Let's try to see how many instances were allocated, right? We can see that you can see here these many instances were allocated. So remember, we are in a consumption plan. There are different plans like consumption plan, app service plan, and premium plan. The plan that I have selected is a consumption plan, where it is going to auto scale as in based on the load. So the available memory, you can see it's around 1.75 gigs. So it has scaled up to these many instances, and you can see that here and there the usage was very high. So this is the power of application insights. Not just this, there's so many things that you can do. You can pretty much run queries. You can set up metrics, you can set up alerts, and do a lot of different things. There's something called logs where you can run queries, and there are different there are different tables. You can do failure analysis, new failure analysis, performance analysis, and so many different things. I can probably select this, and you can see that it shows HTTP trigger. This was what the analysis was. Let me go to workbooks again, and so there are a lot of different analysis. These are like something that is already there. You can also write your own. Queries as well. If I show you inside log, this is basically log analytics tab. You can say response time trend, you do a run, it's gonna run and show you the response time trend. And then there are so many you know uh, queries that is already built in. We can utilize them. Don't worry about the output. It may not really have anything right now because it's a brand new function. These are the different tables that are there: page views, exceptions, dependencies, request traces. There are a lot of things that you can do here. Okay, that's great. Now there is something else inside, built inside Azure Functions. Like I said, the hosting environment for Azure Functions is Azure App Service, and App Service has a really cool thing called diagnose and solve problems. This is something which is inbuilt, and it pretty much tells you a lot of different things. There is a lot of reporting that you can run here, reporting with respect to availability and performance, configuration management, and many more things. Let's say like CPU. Are there any scenarios for? I mean, you can pretty much search here. It shows you all the. So when I click one of these, it's gonna run that in the backend and give you like a report. Like let's say CPU drill down. If I select CPU drill down, it's gonna pretty much select that and give you a detailed report about it. It may take time when you're running it for the first time, but okay, this is not a program. I'm sorry. Like I said, I'm in a consumption plan, so this is not supported there. So there are again two other plans, like I said, a premium plan as well as an app service plan. I assume the same thing here as well. Yep. Let's see if anything like availability and performance. I think there are multiple here. Let's try to run one of them. It is just running a generic availability and performance report. It tells me what is the availability and performance, and I can, if required, I can click on more information. It's going to run another report again. Okay, we saw a demo. Now, what I want to talk about is instance and resource management. Like in consumption plan, we know that Azure Function adds instances automatically as and when needed. A single instance can process multiple requests at once or over time. So, with this in picture, let's discuss about some of the patterns and anti-patterns that you can probably, avoid or follow inside your code. Always set up monitoring tools like tasks and application insights. We just talked about it. Utilize certain resources by sharing them across executions. For instance, HTTP client or SQL client. Like if you see the code here, right? I mean, what we're doing here is we are creating HTTP client objects on the go. So what's going to happen with this is that there will be a lot of HTTP client objects that would be getting created. What would happen with this is you would lose out on sockets. And the right way to do this is probably making it private static, something like this. Okay, all right, moving on. What are the other some more points that we can talk about? If you're planning for a high scale, right, although instances are scaled automatically, there could be scenarios where we may run, like let's say in this case we had one instance and we ran a lot of executions. Like let's say it's set up on a queue trigger or HTTP trigger. There are multiple requests coming in, and you see that some of it is not getting executed, or some of it is probably not. Let's say it's supposed to do some kind of processing and that is not happening, and that probably one of the reasons could be because of how much of load an instance is taking. So although we are controlling the scaling, we have provided something called host.json, where you can pretty much control a lot of different things like max concurrent requests, things like outstanding requests, and so many other settings. In this session would probably in the interest of time, we could not probably jump into host.json and figure out all the settings, but then you can probably go and check that out. It is really helpful to understand and run as in like scenarios like concurrent requests, outstanding requests, and many other. Let's say in scenarios where we have max concurrent requests as 25 and we have 10 instances, it would allow 250 requests to be executed at a time. All right. Some more discussions around do's and don'ts. You can use a sync call, but avoid blocking calls. Like if you see in this example, we're doing an await on push to DB. It's going to return back, But if it's going to be a long call, if it's going to be long running, and if your function is waiting on it, that is not good. I mean, I just discussed that in the first point. No long running functions, there are timeouts. These are the timeouts for different plans. We have consumption plan 2, we are using 2 and 3. So the default timeout is 5 and 10. So likewise, there are timeouts for a lot of different plans. So no long running functions and no timeouts. So write resilient and defensive functions. The reason we say this is because let's say your function is supposed to handle some 10,000 scan through some 10,000 messages and do some more processing, and let's say on the 5,000th message it fails due to a lot of number of reasons. It could be because the load is high, or it could be because there's some kind of maintenance, or there could be some kind of restart that is happening. Your code should be written in such a way that as and when the restart happens, it's not going to start from the first point again. It's going to start something from 5001, right? A good example is handling poison queue messages. If you don't know what is poison queue messages, go check that out. If like I said, if there is if a poison queue, if a message is not really handled correctly, it's going to put it back into a queue, and then you can have another function which will trigger based on the queue trigger and handle that message. That is poison queue messages. Receive messages in a batch as and when possible. We know that there is something called max batch size in host.json, especially in scenarios of event hub triggers. This would be very helpful. There are a lot of practices which we suggest. You can go to this aka.ms/function best practices. You can go and check them out and figure which are those best practices. In the interest of time, I've only selected those which are really affecting our customers. And again, I just want to bring back the focal point of discussion around the maturity of the function apps. All these demos are not ready to show you that these are the things to be done. This is to show you this is what we really have, and this is exactly as per the trends in the current market. And then the most important point about security, I was discussing a point right at the start about PureSec. App service provides hosting environment for functions. So securing functions is as easy as securing your website. Your app services are secured from other customers' Azure resources as well. VM instances, runtime software are regularly updated to address newly discovered vulnerabilities. Communication of secrets like connection strings stays within Azure and does not cross any outbound network boundaries. Secrets are always encrypted and stored. And all communication over the app service connectivity features like hybrid connection is encrypted. So connections with remote management tools like CLI, PowerShell are also encrypted. And there is a 24-hour threat management team which protects the infrastructure against malware, distributed denial of service, and man-in-the-middle attacks, and many things like that. There are some more recommendations that we give and some more concepts that we discussed in these links, function security concepts and function security practices. You can use a lot of different things like firewall, application API gateway, VNet, and NSGs, and try to block things and utilize our security practices. You can go to this particular link where we discuss a lot of security practices that you can utilize based on your requirement. All right, we discussed about all this. Now, functions everywhere. So we have functions that you can run anywhere, from local dev machine to a function service running inside all these three different plans: consumption plan, app service plan, and premium plan, or even in an IoT or on a stack, Kubernetes, anywhere. Okay, all that's great. You talked about so many different things, but what is still hard? In scenarios like chaining, like let's assume that you want to chain 1 to 3 functions. It is really difficult to be done with the current scenario. You will have to set up your own queues. If you want to write long running functions, it is still difficult because we just discussed about timeouts. And if you want to write something called stateful functions, that is also difficult. That is not possible in the current scenario. Function apps are stateless. So again, fanning out and fanning in kind of scenarios. External events, we are dependent on an external event that is happening. We have to wait for a prolonged time. How do we do that in functions? It's very difficult in the current scenario. Flexible automated long running process monitoring, again the long running thing that we discussed. HTTP based async long running APIs. the sync thing that we discussed, and then if let's say something is dependent on an external, pretty much the third and sixth are in line. So there are scenarios where you might have to wait for a long time. There are scenarios where you might have to maintain the state. In those kind of scenarios, we can't really use function apps. So we have something called durable functions, which has been there for quite some time. Durable functions, you can write wrong running orchestrations as single function inside the same function app, create a lot of different orchestrations, a lot of different functions in one single app. I'm going to discuss how we can do that, and you can simplify complex transactions and coordination, easily call a function from another function. Okay, so how does it work? So we have something called starter function, which is going to basically start orchestration. You know what is orchestration? We discussed at the start. What does it do? It starts, you create an orchestrator function, and then it orchestrates and probably provides there are activity functions, like you start a function, then you start an orchestrator function, and from the orchestrator function we call in the activity functions which do your task. So that's how it works, right? We can I'll probably dig a little more deeper into this. This is at a very high level. Let's move on. So this is how it works. This is basically your your orchestrator. We let me go back to the previous slide. This function is what is shown here. Here we are calling function 1, function 2, function 3. These are your activity functions, and we have already utilized this orchestrator function is already called by another function which calls this function, and from this function we call await, and then we call into this function 1, function 2, function 3. Let's try to understand in a little more detail as to how this works. Again, this is the orchestrator function. These are the activity functions. Okay, now I've taken a simple example where let's say we want to say hello AzConf 3 times. It is calling a say hello function, and we have an orchestrator function and an activity function. And another important point is the execution history. This is really important in things like where you want to maintain state, because here, let's say we are kind of chaining 3 different tasks. It's really important to know what has executed and what has not executed, and what state it is in, and all those things, right? So how do we do that? Let's take a simple example. Let's say our function is called orchestrator function. It comes here, and then we have to basically say hello AzConf, and we see that okay, orchestrator started, execution started, say hello. We check the table. Have we already said the hello? This is the history table that I was talking about. In the demo, I'll show you where it is stored and how it looks like. Have we already said hello? Nope. Now let me call the activity function. So the task is scheduled now. Say hello AzConf. So orchestrator has completed and it has gone back because of the await, and now we call await activity function. We call AzConf, hello AzConf. This task is completed, so we have already called it. Now activity function says that it's pretty much done. Now orchestrator function comes back and executes from the start. It's not going to start from here. It starts from the start, and then again checks, have we called hello AzConf? Yes, we have. We just completed it. So basically it just returns the output, hello AzConf. That's all. So it's this is how it works. I think you'll understand it a little better in the demo. Okay, so let me do a quick demo for the chaining of functions that we talked in the slides. I'm going to do the demo. Let me head over to Visual Studio Code. Okay, so here is our code. Let me basically show you what we are doing here. So again, it is pretty simple. Hello orchestration.cs. It has, this is your orchestration function. You see it here. This is your orchestration function, and what is it doing? It is just calling hello orchestration hello, which is the activity function, and calling Tokyo. Sending a parameter as Tokyo, and sending a parameter as Seattle, and sending a parameter as London. Consider these as 3 different scenarios, 3 different functions doing, what you're doing here is you're chaining it up. Now, what can be accomplished in this activity function is basically just saying hello name. and this is the function that calls the orchestrator. Okay. Again, the interesting thing in Visual Studio Code is you can set up breakpoints and you can pretty much run that, okay, and pretty much debug it. And what I've done is I've set up a breakpoint and say hello to see how does it work. Let's try running it. Let's do a debug. By the way, this is in C#. Okay. All right. So it just executed. What it's going to do is it's going to give me a HTTP. It's an HTTP trigger function, obviously. So it's going to give me an HTTP URL, which you can call from, let's say, browser or from Postman or anywhere. I am going to use Postman, and it's already there. I was testing it before. So let me try calling it. So what's expected to happen now is when I call it from Postman, it is supposed to execute my orchestrator functions, and from the orchestrator functions it is supposed to go to my activity function. And where do I have a breakpoint? I have my breakpoint inside the activity function. Okay, let's hit that, send. So let's go back to Visual Studio Code and see, okay, it is actually hitting our breakpoint. Now let's watch our local variables. You can see the first time we're calling Tokyo, and you can see inside the name we have sent Tokyo, which is here. Okay, that's great. Now let's press F5 so that it hits again, because we are calling Seattle now. Yep, Seattle here, and then F5 again, we call London. Okay, that's great. Now press F5 again, and I think we are done here. Now that's interesting. So you see that, you know, we changed the function, we called it thrice from the orchestrator, and that's how it orchestrates. Now what I really want to show you is the history table, you know, if the execution history, which is really important. That's where we were, if you remember the slides, that's where we are going and coming and to figure out what is happening. We have it stored in blob because it, you know, while you're setting up your durable functions, it asks you for all those things. And you can see here, hello Tokyo, hello Seattle, hello Tokyo, Seattle, because the activity function first got called, activity function twice got, second time it called, activity function 3 got called, and then we returned the outputs. So that's how it basically does. This is exactly same that, you know, orchestrator started, the execution started, task scheduled. I've pretty much created a mirror of that in the slides. Let's get back to our slides. Okay, we saw what is durable functions, right? I mean, if you want to do stateful and if you want to do long running, it's a great way to do it. Okay, now what I'm going to discuss is some success stories. We have some customers where we, who have utilized functions, and we're going to discuss some success stories and some more architectures, which is going to help you while you create your. So this is from Segis, who have SEGES. It's a I think it's from Denmark. They are a council. They have utilized functions. If you see the architecture here, it's pretty straightforward. They have something called I think what they do is they have something like farm data, which was pretty much manual, and they had these old traditional systems where the farmer had to pretty much do a lot of things manually. So since they are already Microsoft customers, they had an idea of creating something on Azure and automating things. So this is what they created as a purely Power BI, fully automated thing, where the data from the farms comes in the form of JSON, and there is an Azure function which puts it into blob. Then there is another trigger which pretty much signifies that Azure Data Factory, that the data is getting into SQL. The Azure Data Factory takes that. This is a long running process. It takes some time. It's sort of like an ETL kind of scenario where you take data and put it, and then from Azure Data Factory they again process it to SQL, and from Power BI you have the Power BI data sheets which get exposed to the user. So it's pretty straightforward and it's a great application. You can actually figure out some more scenarios like this at customers.microsoft.com. There are so many customers with Azure functions, and they have discussed about their success stories there. Okay, the next architecture that I want to talk about is the file triggers and transformation. This is a pretty straightforward ETL kind of scenario where you have function apps which are running, which are pretty, there are storage triggers there are functions which are watching the storage triggers, the data rate putting into storage, and this function will get executed on the storage trigger, and then it goes into cool storage, and you use Azure Stream Analytics. And in case there is something that is going wrong, we trigger another function. So this is file triggers and transformations. And then we have Serverless Web App. This is a single page application which uses application gateway, APIM, which acts as a gateway. And from there, we trigger a function app which pretty much feeds data into Cosmos DB. So it's an HTTP GET that happens here. So these are different scenarios where you can use function app. There are a lot of such discussions that happen in. There is a page which talks a lot of different architectures that are there in function. That can be utilized in function app. You can pretty much head there and read those architectures. One more important architecture is the microservices based architecture. What does this do? This is a straightforward one. Here it's a well-rounded system. You can see an orchestrator here, a durable function, a ride share web app. It's like a hypothetical name that we've taken, which calls into APIM. From there we have these APIs which are like, then there is a durable function which is an orchestrator which feeds into event crates. We talked about event crates at the start, and then there are a signal R processor and Power BI and archive trip processor which these are the functions which will execute from the event crate and pretty much create. So the reason we call this is microservices is because you can see there are functions doing a lot of different things here, and there's a function associated for each of like signal R trip processor, Power BI trip processor, things like that. Okay. All right, so these are the architectures that I wanted to discuss. You can head over to the function apps documentation. There are many more architectures that are discussed. The idea of in the discussion of these architectures is to understand the mix and match that you can do while you're designing your applications. To summarize, serverless ecosystem in Azure is well-rounded with components to fit all scenarios. There are things like KEDA. I didn't talk about KEDA in the interest of time, but to define what is KEDA, KEDA is something which integrates with Kubernetes and functions. There is an auto-scaling element that comes in there. So with tooling like these, there is a lot of integration that happens with microservices and enterprise kind of applications. Security is an important factor. As we discussed, there are a lot of things that are already taken in care inside security. And then we saw this, that the tooling is pretty matured. It makes it easy for DevOps and developers and in a lot of different scenarios. We saw that in our demos. And then we have debugging and monitoring app like DAS and application insights. DAS is diagnose and solve problems, which aid you in development and testing and production scenarios. All right, so that's pretty much it. So I wanted to acknowledge Jeff Holland, who is the principal PM manager at Azure Functions, and his team for some of these demos and the great documentation, and also function docs and customers.microsoft.com, which was pretty much the reference for this talk. And these are some of the sponsors for the Azure conference, Microsoft and DevOps partner. And these are the communities. You can pretty much head them and follow there. Some of them out there on Facebook. B.NET is a pretty famous one, Chennai Azure. And then we have Women Tech Network, Women Who Code, .NET Foundation. These are some things that I personally follow, and a lot of cool things happening there. Some more communities again, Open Source Bangalore, Redis Bangalore, and so many of these, Docker Bangalore, and so many of these communities. Hit a follow for them, and it would be great to work with you guys and in the upcoming community for conferences and discussions. All right, that's about it. Thank you very much for your time. Be safe, and if you have any questions, you can continue posting it, and we'll be happy to answer here. Thank you. Have a good one. Bye bye.